Hi, a very good morning to everyone. I'm Jiahao from Wizlogix, the host for today's WizConnect webinar. Wizlogix being in the business for PCB layout design, fabrication, component kitting, and assembly services for the past 20 years. We are glad to invite our internal trainer, Ms. Suriani, PCB Design Engineer, with 14 years of PCB layout design experience to share on today's topic, PCB Design the Easy Way. Without further ado, Sue, please.
Hi, thank you, Jiahao, and a very good morning, everyone, and welcome. Today, I will be sharing about PCB design the easy way. Okay, do you often find that you have difficulty or find it hard to complete your PCB layout design? Or your layout is too difficult, or you're just running out of time? Or you're just new at layout design? Or what specs do you look out for your footprint? And do you need to know what the electronics industry standards are or what the electronics industry are using right now? Is there an SOP for layout design? And you wonder what standards and documents are being used for layout design. So for the benefit of those who are new or not heard about IPC, let me introduce IPC to you. For those who already know IPC or using IPC standards, do bear with me for the next few minutes. So IPC stands for Institute of Printed Circuits. They are actually an organization of volunteers from the electronics industry with strong foundation dedicated to meet industry standards. And their focus is mainly on the standards for the PCB design, manufacturing, and the electronics assembly process. They have come up with documents for standardization throughout the industry. So if you are interested, you can go to the website www.ipc.org to find out more about the IPC organization or the standards that they are using. So IPC classify electronic products into 3 classes. We have class 1, the general electronic products. Class 2, dedicated electronic products. Class 3 is your high reliability electronic products. So now let's go into details on these classes. So for class 1 is your general electronic products. So from the picture here, you can see that these products are not very expensive. So you can expect that to see a lot of these products in the market, mass produced. So that means high volume, and they tend not to last very long, having a limited lifespan. So as long as you can plug in or put in battery and it functions, power on, power off, and perform as what it's intended for, then it's good enough. So in general, we can see children's toys, everyday items in the house or office are usually in this category. So if in the event that this product spoil, you can just easily replace them and they are cheap. And definitely cost is not a very big factor in class 1 general electronic products. Okay, next will be class 2 dedicated service electronic products. Here we have products that require continued performance, and of course we prefer to have them last longer. Moderately long, maybe a lifespan of between 2 to 10 years, and some can even last up to 10 years or more, depending on the usage and the quality. So definitely much better quality than class 1. So you can tell that the quality is much better and moderately better than class 1. So you can find these products in your basic medical services and your high-end consumer electronics, such as your smartphone. And the third class, which is your high reliability electronic products. Here, on-demand high performance is very critical, and continuous service is also required. So the lifespan has to be extra long, spanning decades or even centuries. So the design has to be robust to last very long. So of course, the quality under class 3 has to be top-notch and fail-proof. So products under this category are usually under the aerospace, military, and critical medical service. So just imagine we have satellites, and space shuttle, aerospace parts, aeroplane parts, military equipment, and medical that involves life and death services. So all of them fall into this class 3 category. So definitely you can see that they cannot fail, and on-demand service is very, very critical. So now we know the different classes of IPC and what they represent. So how is IPC related to you? So basically, first you need to know the nature of the product you or your company is making or even developing under R&D. So whether is it a consumer product or is it a business intended product? And what is your demographic or the market that you're targeting? And what kind of power supply that you're looking at? Batteries, plug-in power source, or a continuous 24 hours source required for your product. So then you need to identify the appropriate IPC class, as it will affect the layout design, fabrication, assembly processes. And at the end of the day, it involves money. So the higher class that you require for your product will involve more money. So the classes that you will take a look into for your layout design will be class 2 versus class 3, and whether you will even consider class 1, because class 1 is a very low quality product and does not have very big or high requirement for this product. So you may not even take a look at class 1. And the budget or the money involved in the product or your layout design. How much are you willing to invest in your product, and how much time are you willing to invest in your product? So now, once you have identified the IPC classes, and generally in the product market right now, class 2 is more generally found versus class 3. As I have mentioned earlier, class 3 is for specific or high reliability products. So next, I will talk about the design considerations for IPC class 2. So why I will talk about IPC class 2, not class 1 or class 3, because like I said earlier, a major percentage of products around us are actually class 2. So class 2 are actually a general and rather standard classification that is recommended by IPC and practiced rigidly in Wizlogix for PCB layout design. So here there are 3 considerations that are important in layout design. Design for manufacturing, DFM, design for assembly, DFA, and design for testing. So let's take a look into what these design considerations refer to and what they represent. So first, for design for manufacturing. So of course, when you design a layout, you would want to get the physical board. So for design for manufacturing, this ensures that your PCB layout design are manufacturable or be able to be translated from a design into an actual printed circuit board. So whatever that we include in the software for your design layout, we do have to ensure that it can be processed and can be manufactured and work out perfectly as what the product requires. So the main objective is to ensure the manufacturing process from design to the actual product runs as smooth as possible as what the design requires. So the first thing we need to consider is the layer stack up. So what kind of layer stack up are you looking at? Is it a 4 layer, 6 layer, 10 layer or more? So how many copper layers do we need? And circuit boards exist in single layer for a one-sided board or in even numbers from 2. So you will always find as even number layer count, 2, 4, 6, and so on and so forth. Do take note that the more layers you have on your PCB board, the higher the cost will be, because copper costs money. So the layer stack up will have a direct impact on your impedance specification, on your critical signals, or even your sensitive signals. On top of figuring out the number of layers, we also need to allocate reference planes for power or ground flow. Of course, you need power to plug in your product or to ensure that your product is running. So we need to allocate layers for power and ground flow, as well as feedback path for sensitive or critical signals. So do have a discussion or do consult on to have a consult on your product on what kind of layer count that you're looking at. Okay, the more layers you have, the more money you need to fork out for the PCB board. Next will be the right copper thickness. So besides the copper foil layers, the layer stack up consists of other layers like your pre-preg and your PCB core. The PCB core is the core material that provides the rigidity to the PCB and also act as a heat conductor to draw away heat from the PCB board so that your board does not heat up too much. And then we also have other layers such as solder mask and silk screen. So copper files here is shown in this kind of format. They are actually in rolled coil foil. They are rated in ounces from ½ ounce all the way to 3 ounce. So normal trace routing usually requires half to 1 ounce, and 2 and 3 ounce are usually reserved for high power design or even design with high current. So for PCB thickness, the total PCB thickness inclusive of your pre-preg and your core material, it ranges from 0.8 mm to 1.6 mm. So you need to find the right copper thickness for your product. Okay, and it also depends on your PCB application, the form and function. So do check with your PCB manufacturer, or you can check with us on the right layer stack up and its specifics. Okay, next will be the proper copper balancing parameters. Besides having a well thought out layer stack up and layer assignment, the stack up has to be configured symmetrically for the purpose of copper balancing. So what is copper balancing? Copper balancing ensures that your board is evenly distributed with copper, like your traces, your vias, and even copper plane areas, to reduce the risk of bow and twist so that the board do not bend or warp during the manufacturing or assembly process, or even during the usage process. And copper balancing actually helps to enhance the overall quality of your printed circuit board when manufactured in panel form, and which makes the board mechanically more stable. And then copper balancing also ensures that you have better copper weight distribution. So you do not want to have one side of your board to be to have more copper than the other side, or you have more copper on the right side versus the left side. So you want to have a better copper distribution. Okay, so here I have an example of the layer stack up of a 10-layer board. And as you can see that this is the layer stack up, including the pre-preg and the core, as well as the one on the right side, which is the actual layer count. So you can see that the stack up here is a 10-layer board. There is a specific number of signal versus plain layers. So if you were to look at the board or look at the the layer stack up configuration, for a 10-layer board, the middle line will be between layer 5 and 6. If you were to look at layer 1 to 5 and 6 and 10, you can see that they are actually a mirror representation between top and bottom half. Okay, so this is an example of a good stack up for proper copper balancing parameters. Then we need to think about the adequate reference plane or feedback paths. So what requires this factor? Okay, in your layout design, you have critical, sensitive, or even impedance signals. So they require the proper reference plane and feedback paths to prevent crosstalk or EMI, EMC issues. So when we think about the layer stack up and the number of layers, we need to think about the adequate or sufficient reference planes in the layer stack up, as well as trace width and spacing clearance. They are also equally important. So reference plane and feedback paths helps to sandwich the signals from EMI and crosstalk issues. So other than using the reference planes, we can also increase the trace width or the spacing clearance from other signals to alleviate EMI, EMC, and even crosstalk problems. Okay. So the pictures here pictures here show the aggressor and victim traces and how we can space them out by doubling or even increasing the space clearance. Next will be the routing topology. For routing topology, we need to consider the number of connections or nets in our layout design, the signal versus the power and ground layers, and this refers to your layer stack up again, your high speed and versus your low speed signals. So try to keep your high speed and your low speed signals as far away as possible and try to group them in their logic families. And whether you're running signals at the microstrip level, which is your external layers, or your strip line level, which is your inner layers. So you have to consider the routing topology required for your layout design. Another factor to think about for your DFM will be your via technology. So via are actually vertical interconnect access. So they are actually holes that pass through the layers of the board for the purpose of conductivity. And each hole functions as a conductive path through which electrical signals are passed between circuit layers. So in a via, as you can see in the picture here, there are two layers where two pads are in corresponding positions, which is a start and end point. Okay. For example, your plated through hole, you have the start here, which is the top layer, and the end point, which is the bottom layer. So, for example, a two-layer board, you have the top or the start pad will be at the top side, and the bottom pad will be the end side. So likewise for a 10-layer board or a 6-layer board. So you have the same concept for a via. And a via is actually made up of a barrel, pad, and antipad. Okay, the barrel refers to the inner plating in the via itself. And then the pad is a corresponding pad that connects to your circuitry. And then antipad is actually the clearance area between your pad and other unconnected copper layer. So besides talking about via, we also have to think about the aspect ratio. Aspect ratio refers to the thickness of the material or the thickness of the PCB board versus your via diameter. So you cannot have a very thick board with a very small via. This will actually affect the aspect ratio and the yield of your PCB board. So the higher your aspect ratio, the less likely the yield that you can get from your manufacturer, and the more costly it will become. Okay. So the next consideration that we need to look out for will be the design for assembly. So of course, for design for assembly, we need to think about the components that are involved in your layout design. The components required has to be able to be assembled or mounted onto the board successfully. So the main objective is to ensure the assembly process runs as smooth as possible without hiccups or without any interruptions on the assembly process. So to ensure that you have a proper or you conform to the design for assembly processes, do plan and organize your component placement before you start your layout design. You can have a sketch like what I've shown here, or you can actually have a discussion on what components or what circuitries to put on which direction. And when you do the planning and organization, you ensure a smooth assembly process at a later stage. Group your logic families in each different category. High-speed signals should be within its category versus low-speed signals in each category. So think about your high-speed versus your low-speed signals and try to space them as far apart as possible. Give priority to your high-speed. Ensure that the critical or even high-speed signals have a proper feedback path or the reference planes. So the feedback path will be referring to your the connections on the same layer or traces on the same layer, and the connector location. Ideally, IPC recommends that connector to be placed as far away as possible from your high-speed logic families. Of course, this is also determined by the product design as well as your product requirement. Next, prioritize the location of components for your critical signals. And this involves your impedance control nets or traces, your sensitive nets, for example, your op-amp, clock signals, or anything that has a sensitive nature to your connections. And any critical nets, you can talk about LAN signals, USB if you have, or even your Wi-Fi. Okay, because we are going through a smart technology right now, so you will have to face, or you have to deal with critical signals in your design from time to time. So other than that, we also have to think about heat sensitive components. Heat sensitive components are components that draw or generate a lot of heat during processes or during the usage or the lifespan of the product. And heat sensitive components can generate heat or can transfer heat by conduction or by convection and radiation. So if the heat transfer is by convection and radiation, you have to allow in ample space for air to cool the components down, or for the heat to be dissipated out via heat sinks. So this is an example of a heat sink, whereby heat can be directed out of the PCB board onto the edges of the heat sink or the heat fans here into the open air. So then the product will actually reduce the temperature rise by significant temperature degrees. Okay. So in relation to heat sensitive components and the amount of space required, we also need to think about the component clearance area. So components that are critical, like your BGA, your ICs, your those that require heatsink, will definitely need greater clearance area as compared to your discretes or your smaller ICs, or even your connectors. So generally, IPC states that this kind of components, whether is it sensitive components, critical components, or even if it's a high or even a tall component, require 3 to 5 mm clearance. Okay, so but then it also depends on the amount or the space area that you have in your PCB board. So in this picture here, on the right here, it states that between discretes and ICs, you should have a minimum of 3 mm spacing. So this is just referring to small components or small components with a smaller body. Okay, so IPC do have a standard for this. So do refer to the correct IPC documents for this, or you can refer to us at Wizlogix. So next will be design for testing consideration. So in this section, this is for the main purpose of testing, to ensure that the connections in your layout design actually translated properly into your PCB board. So for design for testing, or DFT, all fabricated boards are subjected to electrical testing. So the main purpose is to actually monitor the connectivity state of the PCB using various capacitance and resistance tests. So capacitance test is actually to check for short and open circuits. So you do not want to have your board to have open nets or short nets. So this is not a very good product if you can get this kind of results. And resistance test to actually measure the copper conductor resistance using current. So if you have low resistance, that means your copper is of a good quality. And if you have high resistance, that means your copper has oxidized or eroded. Okay. So how do we test these boards? We make use of test points as the point of contact for probes for this electrical testing. So for test points, generally it will be in 1 mm round copper pad, as you can see in the picture on the left, with a 1 mm keep out area. So to ensure that probe points are able to access these test points without hitting other components or even other test points. Okay, so test points are generally used for various types of electrical tests. You have the flying probe, where you have probe points running all over the PCB board using the AOI or automated optical imaging machines. You can have test jigs whereby probe points are individually placed on points required on the board. Or you can even do a manual testing. That means you can use the 2 points of your multimeter and you can do a manual testing on your own to check whether the connections are correct or whether is there any short or open circuit. Of course, because it's a manual testing, so this is a point-to-point testing. So when we implement or when we incorporate design considerations for DFM, DFA, and DFT, we can be assured that we also follow the standards for IPC, we are assured of a good PCB layout design that meets IPC standard. So the design for considerations for DFM, DFA, and DFT goes hand in hand with the IPC standards. So what happens if you still face issues completing your layout design? So you do not know how to complete your layout design and you have difficulty using your design software. So, or not sure which software to use for your PCB layout design. So some software will be able to handle a high current board, or some software can only handle simple design, basic designs. Stuck on nets or connections, you face crisscross connections, or you're not sure which layers are these nets supposed to run through for your critical signals, or you just need another set of eyes or another angle to view these nets and connections, and you find that your components cannot fit in and you have too many components. You have too many bulb caps, filtering circuitry, filtering caps, filtering resistors, and you need advice when it comes to placement. You don't know who to look out for, and you need advice. And you have trouble with impedance matching. So let's say, for example, you require the differential pair 110 ohm, but when you run simulation on your layout design, it doesn't match. Probably you only can get 90 ohms or even 75 ohms. So what do you do? So, and then you need a correct PCB stack up, but you're not sure. Should you increase or should you decrease? Or should you reroute the whole board or do a planning or strategize on your component placement as well as routing? Or you just need a hand for your PCB layout design. You don't want to do the PCB layout design and you simply don't have the time and you don't know who to ask for help. So here we can help you with PCB design the easy way with Wizlogix. So crafting perfection with passion is our tagline. So one reasons to engage Wizlogix Private Limited, there are 10 of them that are stated here. Okay, Wizlogix, we are the largest PCB design bureau with certificates in AS9100 and ISO 9001 standards for PCB design and management of subcontracted PCB manufacturing, assembly, and technical support. We have a comprehensive PCB design service for your product needs. So we can assist you and perform schematic entry, footprint creation using the IPC standard 7351, as well as placement and routing all the way to Gerber checking. Okay, Gerber checking ensures conformance to DFM, DFA, and DFT requirements. And we do have the latest design tools for your every design needs. We have high-end tools comprising of the Cadence Allegro, as well as Mentor Graphics Expedition. And we do have mid-range tools such as the Mentor Graphic Pads, as well as Altium Designer. And for the Gerber checking as well as documentation, we have Chem 350 or downstream Chem 350, as well as Blueprint PCB. Number 4, we implement the best practices and techniques in the industry conforming to IPC standards. So this is relevant for Class 2 and Class 3 design. Okay, so all the standards that we are using, we are we are actually conforming to IPC standards. Okay, on top of conforming to IPC standards, we are also a one-stop solution provider of PCB related solutions. So other than providing PCB layout design services, we do have PCB fabrication solution, component kitting, PC assembly, or we normally call it as full turnkey solution, as well as we do engage experts on technical competency courses. So because we are a one-stop solution provider, we are also capable to advise on PCB-related issues for the design, manufacturing, assembly, and even courses. And our promise to you will be quality design with on-time delivery. So to ensure quality design, by engaging us, you have access to our talented pool of PCB design engineers with many years of design experience. And as you know, and I think everybody knows, that PCB design is a very tedious and consumes a lot of time, you know, designing, planning, routing, placement, and so on and so forth. So it's a very tedious and lengthy process. So when you engage us, you can actually outsource this tedious process to us. So you can liaise with us on your specific design needs, and we can work with you hand in hand to produce a good layout design for your product. And to maintain a design department in your company, you need to maintain the overheads such as software maintenance, the headcount for the design layout process. So in order to streamline your company resources, focus and budget, you can outsource your PCB layout design works to us, and then you can streamline your company as you see fit. So you save costs on maintaining software licenses and headcount for the PCB layout process. So what are Wizlogix design capabilities? We are able to provide a high layer count PCB. So definitely high layer count is desirable, but it also depends on your PCB board or your product design. So the more copper layer count that you require, the more it will cost to build or fabricate your PCB board. So do refer to your own product design or your design requirements on the appropriate number of layers to be used for your layout design. We are capable in designing layout design or boards that require blind, buried, or micro vias. And these are usually used in HDI or high density interconnect boards or design. And we are capable in designing mixed signal, analog digital, high power circuit design, high speed, as well as high density design. And on top of that, we are also capable in designing micro BGA, BGA, ASIC, ICs designs. And if you require layout design for control impedance, for signal ended and differential pairs, we are also capable with match length traces. And we do have experience in designing flex and rigid flex design. So the HDI technology is also referring to the blind, buried, and micro vias. Okay, so on top of, I've been talking about layout design. So how do we ensure that your layout design conforms to standards, conforms to manufacturing capabilities, as well as assembly? So we provide Gerber checking using CAM 350, the software that we use in-house. So what do we do, or what do we check during this Gerber checking stage? So the main checks that we do will be compliance to specifications for DFM, DFA, and DFT. So it ensures a smooth process for these 3 steps. And for Gerber checking, we make use of this IPC D356 netlist to check for open or short circuits. And this is to ensure that your layout conforms to your product requirement. We do have in-process cross QC check for our Gerber checking over layout design. And design rules check via streaming is also performed using CAM 350. And we also implement cosmetic screen modifications and checks for things like or labels such as your company logo, product requirement, product name, any ROHS stickers or ROHS logo, lead-free logo, and we are able to check for this using our Chem 350. So once the design is complete and we have completed the design layout as well as the Gerber checking, these are the deliverables that we will provide upon project completion. The design database involves your source file, your schematic file, as well as your layout design file. Fabrication drawings, those are information and instruction for fabrication or manufacturing. Assembly drawing includes instruction and information on the assembly process. Gerber data will be your 2D vector format data for manufacturing process. Drill data, this will be in a format called NC drill, meant for the location of all the drills, for your vias, for mounting holes, for your component holes, as well as its quantity. And any customized output file required by our customers or by you. So on top of performing layout services and Gerber checking, we do have technical competency courses conducted by myself. And one of it will be the basic PCB design course. Okay, in this course, you will be able to learn the basics of PCB design, which is a CAD tool based lesson or course. This is to enhance your design workflow. So for those who are new to PCB layout design or those who jump industry into layout design or even new grads, it's good to enroll in this course so that you learn the basics of PCB design, and you can select a type of CAD tool that you prefer. And then we also have the Gerber Techniques course. Here you can learn the best practices of Gerber skills to enhance your PCB design. You may have an in-house designer or an in-house layout engineer, and the layout engineer need to have certain skills to ensure that your PCB layout conforms to the FM, the FA, and the FT considerations. So it's good for your layout designer or any layout designer to go for this course to learn the best techniques for Gerber skills. And we also have customized PCB related courses. And these courses actually to cater to the specific PCB design needs of our clients. So this course is customized and you can actually work with us to cater to the course or PCB related course that you require. Okay. So I will pass the time back to Jia Hao.
Thank you, Sue, for your mind-blowing and very lively sharing today. With all that, we have come to the end of today's webinar. Hope to see you next time. Take care, goodbye, and have a great day ahead.